All right, and then our final example for chapter 7, for that matter. The Funsize Snickers bar is supposed to weigh 20 grams, and there is a penalty for selling candy bars that are under their advertised weight. It's pretty severe. So the manufacturer calibrates the machine so that the weights are normally distributed with a mean a little bit above that 20.1 grams. But the quality control engineer is a little concerned that maybe the candy bars are coming in underweight. So he takes a random sample of 11 candy bars, weighs them, and gets the data shown in the table. Should we shut the machine down and recalibrate? It's expensive to do that, but so is getting fined. So we're going to conduct the test at the 1% level of significance. In other words, we want to really, really be sure if we're going to shut this down. There's a very good reason to do it. All right, so first thing, verify that the sampling distribution is normally distributed. Well, it says that the weights of the candy bars are normally distributed, and so we're good to go there. Okay, we've got a normal distribution of the population. All right, write the null and alternative hypothesis. So the mean is supposed to be 20 grams, and we are perhaps concerned that it's smaller than that, so less than 20 grams. You may be asking, why don't we use 20.1? Well, the standard, the advertised weight of the candy bar is 20 grams. So we don't care if they're coming in at 20.1 grams. That's actually a good thing. What we care about is if they're coming in under that specified 20 grams. All right, to find the sample mean and the sample standard deviation, you will need to enter that data into list 1 and run a 1 variable statistic. We should find, or hopefully you will find, that the mean of the candy bars is 19.90 grams with a standard deviation of 0.54 grams. For the test statistic, so now we're going to go back into stat, into tests, and because we have data, you will be selecting the data option. So remember, once you do that and you select data, go ahead and hit enter so it switches over to what it is you need to put in. The null hypothesis value is 20. List is wherever you put your data, I assume L1, frequency again at 1, and this time for the mu, we want to test that we are less than the mean, so make sure you're testing that one, and then go ahead and calculate. The t-value that I am getting is negative 0.6256. The p-value is coming out at 0.2728. Now, one disclaimer, I may be off by like a digit or so in that t-value and p-value from what you have. When I entered in this data, I actually entered the mean and standard deviation accurate to 4 decimal places originally, and I'm using my notes to rewrite. So if they're off by just a smidge, that's probably why. Okay. Decide whether or not to reject the null hypothesis. Well, again, we are looking at whether we are in this bottom 1% of all candy bars. We are here at 27.28. We're like way out here in the middle somewhere. So we are going to not reject the null hypothesis. And so our conclusion will be that we don't have enough evidence. We don't have enough evidence to support the claim that the candy bars are underweight. Or again, however it is that you would like to say that, okay, that they weigh less than 20 grams or whatever. All right, that wraps up chapter 7. So please go ahead and do the 7.3 homework. And as always, be posting any questions you have to the forums, or make plans to chime in during my online office hours. I am here to help you however I can.